So I'm going to give you guys some definitions, and then so what a minimal Groebner basis is, and then what a reduced Groebner basis is, and then I was going to say a little bit more about the elimination theory, what we did last time. So this was solved one of our principal problems, and then we did a computation previously, but I didn't write out all the theory. And then I was going to start doing some proofs related to these things. Okay, so let me just get started. So some terminology. Okay, so first, definition. Okay, so a minimal Groebner basis for an ideal I is a Groebner basis. I guess we should do capital G's since I'm doing capital G's. Such that, so G1 to GR for I, where none of the leading terms divide each other. So the leading term of GI does not divide the leading term of GJ for I not equal to J. Okay, and so so there's kind of okay, so this is a minimal Groebner basis, and then let me give you a definition. Another definition. So there's kind of a stronger condition that you can impose, and so a reduced Groebner basis and this is what the algorithm in Sage outputs. So a reduced Groebner basis is a Groebner basis okay, again, a Groebner basis for an ideal, but I'm just going to not write that. G1 through GR that satisfies a stronger condition, right? Where each GI, and again, for all of this, a term order needs to be each GI is monic. So a term order needs to be specified. Each GI is monic. Okay, so that means that the leading coefficient of GI is 1, right? And 2, no term of GJ is divisible by a leading term of GI. Okay, and the terms are just, every polynomial can be written as a sum of monomials, and then those monomials are the terms, right? Well, without the constants. Okay. Okay, so how do you get a minimal Groebner basis? So this is what, okay, so let me just say something about the reduced Groebner bases. Okay, so the upshot of these is that these exist. So these things exist. And they are unique. Okay, so this is what Sage outputs. Okay, so this is unique for a particular term order. Okay. All right. So that's why we care about reduced Groebner bases. So a minimal Groebner basis is you can just get rid of junk. Okay. So for these, right? Okay. So if you have a Groebner basis, let's just say this is a fact here. Okay, if you have a Groebner basis, where, let's say G1 through GR, where each of the GIs, so where L, the leading term of GI, divides the leading term of GJ, right? You can just throw away the GJ, right? And still have a Groebner basis. Okay. Okay. So this is how you. So this is how you obtain a. So this is how you obtain. Uh-oh. So how you obtain a minimal Groebner basis. Okay. All right. Okay, and let me just point out here that you're so in this bottom left thing here, you're free to flip back and forth if you want on your own because I unlocked this. Well, I mean, you should unlock this too. So my unlocking it shouldn't flip your pages. It'll just flip mine. Okay. By the way, this page here was just from office hours or after class. I can't remember, but someone was asking about one of these problems. All right. Okay. So so this is the terminology that I owed you about minimal Groebner bases and reduced Groebner bases. I'm thinking about adding some exercises in related to this. Maybe some other theoretical things. So look out for that.